Hey everyone, and welcome to another deep dive. Today we're going to be looking at something pretty interesting. It's called AC, and it uses aluminum to fight germs.
Aluminum, huh? That's not the first material that comes to mind when I think of, high-tech antimicrobial stuff.
Right, look, I thought the same thing. But the presentation we're diving into is all about how EC is being used in hospitals. And get this, they kick things off with a quote about finding the elixir of life.
Okay, well, that's certainly an attention grabber. So what exactly is EC, and where does the aluminum fit in?
So EC actually comes in two forms. First, there's ECA, which gets applied directly to aluminum surfaces. It's kind of like giving those surfaces a built-in defense system. And then there's ACB, which works alongside ECA to make it even more powerful. But here's the really interesting part. ECB can actually work in the air and water, not just on surfaces.
Okay, now that's pretty cool. But how does regular old aluminum turn into this germ-fighting machine?
Well, it all comes down to some pretty clever science. They found a way to bond silver ions to the aluminum. And when moisture hits that surface, bam, those silver ions go to work, creating what are called reactive oxygen species.
Reactive oxygen species. That sounds a little intense. Could you break that down for us?
Sure. They're also known as hydroxyl radicals. Basically, they're these powerful oxidants that can break down the cell walls of bacteria and viruses, stopping them dead in their tracks.
Ah, so it's the silver ions that are the real heroes here, and the aluminum is like their trusty sidekick. That makes sense. Silver's already known for its antimicrobial properties, right?
Exactly. And that's one of the things that makes these so exciting. It takes advantage of that power to fight even those superbugs that are resistant to antibiotics, which is a huge key concern, especially in hospitals.
I see what you mean. It's like we're moving towards preventing infections rather than just treating them after the fact, creating environments that are actively hostile to pathogens.
That's a great way to put it. Instead of cleaning up after the germs, we're creating surfaces that are constantly fighting them off.
Exactly, a proactive approach. And think about the potential impact on healthcare-associated infections, not to mention the cost savings.
And it's not just hospitals. Imagine the possibilities in food processing plants, schools, public transportation. The applications seem almost endless.
Okay, color me intrigued. But does this stuff actually work as well as they claim? What kind of evidence are they presenting?
Well, they have a whole section devoted to studies and test results. And some of them are pretty impressive. For starters, they tested easy-treated aluminum against that virus that causes COVID-19, SARS-CoV-2. They found a significant reduction in the amount of virus on the treated surfaces. And this was back in 2021 at a reputable university lab.
So it's not just some, made-up data. They've got some real science behind it.
Exactly. And they didn't stop there. They also did a study comparing easy-treated aluminum food containers to your typical glass and plastic ones. And the results. The aluminum containers showed a dramatic reduction in bacterial growth, even after several days.
Okay, that's compelling, especially for people who are worried about food safety and, keeping food fresh longer.
Right. And it ties into the whole sustainability thing, too. If food stays good for longer, we waste less.
There was one study in particular that caught my eye. They actually put easy-treated panels in a public restroom and tracked the bacteria levels over time.
Oh, yeah. I remember that one. Did it actually make a difference, like in a real-world setting?
Get this. They found total bacteria elimination in just 6 hours, which is pretty amazing when you think about how many surfaces we touch in a day.
It makes you realize how easily germs can spread and how many potential hotspots there are, like doorknobs and shopping carts.
It's one thing to test things in a lab, but to see these results in a real-world environment is impressive.
Absolutely. But this presentation is really focused on hospitals.
Sure.
And they lay out a pretty detailed plan for implementing EasyWheel in those settings.
So they're not just saying, hey, here's some cool tech, good luck figuring it out?
Nope. They've actually developed these kits designed for different spaces within a hospital. Patient rooms, waiting areas, corridors, you name it.
Oh, so they're like pre-packaged solutions. That's smart. It shows they understand the specific needs of hospitals when it comes to infection control.
And they're not just focused on new construction, they also offer retrofitting options for existing hospitals.
Yeah.
So you don't have to build from scratch to take advantage of the technology.
That makes a lot of sense. Opens up their market considerably. So what kind of proof do they offer that the stuff actually works in hospitals?
Well, they actually include an independent assessment from the Albanian Ministry of Health. So it's not just the company talking themselves up.
Oh, wow, an external source. That's always a good sign. What did that assessment say?
They focused on two key areas.
Right.
A virology lab and a laundry room. Places where you'd expect a lot of microbial activity, right?
Absolutely. High-risk zones for contamination.
For results. Nearly 100% reduction in bacteria in many cases. They even quote the Director of Epidemiology and Infectious Disease Control, praising the effectiveness of the Easy-On system.
Wow, that's a pretty strong endorsement from a respected authority. It sounds like they've got a pretty compelling case for using Easy in hospitals. But I'm curious, did they mention any other potential applications outside of healthcare?
They did. They briefly touched on applications in the food and beverage industry, construction, and even water distribution systems, which is pretty interesting.
Water distribution systems. Now that's intriguing. Tell me more about that.
Well, they highlighted a case study where they used Easy to combat Legionella bacteria, which can be a big problem in stagnant water systems.
Oh yeah, Legionella is nasty stuff. It can cause a pretty serious type of pneumonia. So how does Easy help with that?
It tackles the problem in two ways. First, the surface of the treated aluminum is really slippery, which helps prevent biofilm from building up. That's where Legionella likes to hang out. And then on top of that, the silver ions actively kill any bacteria that are present.
So it's both preventative and proactive. That's a pretty clever approach. And it ties into another trend we're seeing, which is using technology to create more sustainable solutions.
Exactly. Traditional methods for controlling Legionella often involve harsh chemicals and lots of maintenance. So if Easy can offer a more effective and environmentally friendly alternative, that's a win-win.
I'm curious, did they do any studies to see how well it works against Legionella?
They did. One study in particular stands out. They introduced a high concentration of E. coli bacteria into water with a high surface area of Easy-treated aluminum. And guess what? They eliminated all the bacteria within an hour.
Wow, that's impressive. It really speaks to the potential of this technology, not just for improving hygiene, but also for tackling some pretty serious public health concerns in a more sustainable way.
It really does. So far, they've made a pretty convincing case for ECA. It's antimicrobial, durable, versatile, and they've got a growing body of evidence to back up their claims. It's pretty exciting to think about the possibilities.
I agree. It is exciting. But, it's important to approach this with a healthy dose of skepticism. As with any new technology, we still need to consider the potential downsides, the cost implications, the long-term effects. There's always more to the story, right?
You're absolutely right. We've covered a lot of ground today, from the basics of how EC works to the potential applications and the evidence supporting its effectiveness. But there's still more to explore. In this part of this deep dive, we'll delve into some of the financial aspects of implementing EC and look at how they're positioning this technology as an investment, not just an expense. So stay tuned.
As we dig deeper into this ESI technology, what really strikes me is the emphasis they put on the financial benefits, especially for hospitals.
Yeah, they really hammer that point home, don't they? It makes sense, though, when you think about it. Hospitals are constantly battling infections, and the costs associated with treating those infections can be absolutely staggering.
Absolutely. They highlight how lower infection rates, shorter hospital stays, fewer ICU admissions all contribute to significant cost savings for healthcare facilities.
And they don't stop there. They even go into the economic ripple effects, like the impact of reduced mortality rates and the lower risk of hospitals having to pay out for those tricky hospital-acquired infections.
It's a clever strategy, really. They're speaking directly to the bottom line concerns of hospital administrators, always looking for ways to boost efficiency and, cut costs.
It's almost like they're saying, look, invest in this technology up front, and you'll see a return on that investment down the road.
Exactly. Presenting EZ as an investment, not just an expense. But do they back up these claims with any hard numbers? Do they provide specific examples of potential cost savings?
They do. They actually offer some pretty compelling projections. For example, they estimate that even a small reduction in hospital-acquired infections could save a hospital millions of dollars annually. And they support these estimations with data from real-world studies and reports.
Okay, that's impressive. It's one thing to make general statements about cost savings, but it's another to provide tangible evidence based on actual data. That definitely lends credibility to their claims.
And they go beyond just providing numbers, too. They actually offer on-site business case analyses to help hospitals assess the potential ROI. They even have test projects and offer assistance with planning and implementation.
Wow, it sounds like they're really pulling out all the stops to make adopting this technology as easy as possible for hospitals.
Exactly. They're positioning themselves as partners, not just vendors. And their approach goes beyond just the financial benefits for individual hospitals, too. They also highlight the positive ripple effects for public health in general, things like increased overall safety reduction of waste and better resource allocation.
And they tie it all back to that growing emphasis on ESG, environmental, social, and governance factors, which are becoming increasingly important for businesses these days.
Right. It's a smart move.
Yeah.
By aligning EASYs with these broader societal goals, they're not just talking to hospital administrators anymore, but to a much wider audience: investors, policymakers, and even the general public who are becoming more and more aware of these issues.
We need to be thoughtful and we need to be responsible.
Absolutely. Well, we've covered a lot of ground in this deep dive, from the microscopic world of silver ions to the vast complexities of microbial ecosystems. We hope you found it informative and thought-provoking. And we encourage you to continue exploring these issues, asking questions, and seeking out different perspectives.
Because ultimately, it's about making informed decisions that benefit both human health and the health of our planet. And that's something we should all be striving for.
Well said. Thanks for joining us on this deep dive into the world of antimicrobial technology. And until next time, keep exploring, keep questioning, and keep diving deep.